This video covers creating a new plant model with the HPC Plant Builder. After you've installed the HPC software, it will create a directory called HydroPlant Performance Calculator in the subfolder that you chose, where you chose to install this software. And there will be 3 subdirectories, subfolders, and there will also be 2 workbooks. And this workbook, HPC Plant Builder, is really a program that enables you to create a new plant model in a streamlined fashion. So I can double click on this workbook to open it, or accordingly I could click on the shortcut that's on your desktop after the installation called HPC Plant Builder. So I double click on the file and that opens HPC Plant Builder. And what is shown is the first worksheet. It's a navigation worksheet. It shows what tasks I need to complete to do a plant model. The light gray ones are the ones that I will or haven't been performed yet, and the blue one shows the next task to perform. And it says double click on a cell to begin a task, so I'll double click here to load a plant. We're going to create a new plant, and I'm going to create a 2-unit plant. This is in the installation software. There's a Plant Builder templates directory. Under that there's a 2-unit plant, and this is a 2-unit template, so I'm going to start with this plant workbook by double clicking on it, and then I'm going to save this in a directory. So I go to HydroPlant Performance Calculator. I'm going to create a new folder called Plant Models, and I'm then going to create a new folder in that directory called 2-unit demo. And I'm going to change the name of the file to the 2-unit plant and save it to that directory. And after I've done that, what it did was in the plant models, and there's a 2-unit demo, which are the folders I created. It's created 3 workbooks, which is the 2-unit plant, the Unit 1 and Unit 2 workbooks, and it simply copied these files from that 2-unit template. And it also created the software created another unit properties workbook, which it uses to streamline the processing of the files. So, and when it did that, it highlighted the different tasks that it's already complete. And so if I double click on calculation properties, this will navigate to the plant workbook calculation properties worksheet, and it shows that these tasks are completed. So if I click here, it returns, it returns right away. But if one of these properties are missing, for example, if we're missing, there's error trapping to let you know that you need to set these values so it can proceed to the next step. So I'm going to change that back to 5. It's complete now, and I'll return to the plant builder. So there's a plant properties worksheet in the plant workbook, and this has items as plant name, case name, number of units, and information to enable this program to compute the specific weight of water for efficiency calculations. It has a unit properties workbook. It shows the details of each of the units. It shows the type of unit, the unit number, a unit index, and there's a unit workbook associated with each unit. So the unit index is typically used to denote the unique units within the family of units. So for many units at a plant, they are operated based on identical unit characteristics. And if that were the case for this plant, then you could have the Unit 2 might have a unit index of 1, and in that case, this would have the same unit workbook as the previous one. But they're different, so we're going to change it back to Unit 2. I can navigate to those unit workbooks by simply double-clicking on the unit workbook cell. It opens that directory, and then I double-click on Unit 2 to specify that unit for the Unit 2 workbook for this unit. And so the unit workbooks, let's look at a unit workbook quickly. They contain the unit characteristics. So the first one of the sheets is the turbine flow versus head and power. And this shows the turbine, the turbine flow as a function of power and head. And then it also shows the generator efficiency. So this is the turbine performance characteristics, and the generator efficiency is the generator characteristics, and those two combined, from those two combined, we create the unit characteristics. I'm going to close this workbook. And then there's also a polynomial curve fit. That's important because a polynomial curve fit is used to compute the optimized plant dispatch. And I also need to configure the data import because data are imported to review the unit characteristics to ensure that the unit characteristics are appropriate for the data, that they extend far enough to cover the full range of power values, power and head values. And so what we have here are different items, different data values, and these are required for the analysis. So we have to have a date time value, a headwater, a tailwater, a unit power, and unit power values for each unit in the plant. And so since this is a 2-unit plant, there's only 2 values there. If this were a 3-unit plant, there'd be a unit power 3, and if there were 4 units, it'd be unit power 4, and so on and so forth. We have to specify which title, a data title, or a data tag, and a column number. So let's look at a data file. So we're going to import, in the demo data files, we're going to import monthly data, and we're going to import a text file. So we're going to import this file, January 2004, and this is what it looks like. So there's a date time, which is in column 1, headwater in 2, tailwater in 3, unit power in 1 and 4, and unit power 2 and 5. And so that's what the file looks like. And that's how it's set up to import. We're gonna specify a column number for this case, so it's 1, 2, 3, 4, 5. We can also specify filters by there's a drop down. We can specify this type of relationship: greater than, equal, less than, or equal to. For this data set, it's important to have them greater than minus 100 because minus 999 is an error code that's used. So for the file import routine is going to be, we're going to import a text file. It's going to be comma delimited. And the title row number is 1. The first data row number is in 3. And now we need to specify a file to import. And to do that, these yellow cells, when it's highlighted in yellow, that means it's going to start a file open dialog box so we can browse to that file. These are demo data files, 2-unit monthly. And it's January 2004 as we're going to look at that data set. And so now we've specified the file. And I can go to this green cell, cell 11, and double click to navigate back to Plant Builder. And that's successful. So now the next step is to import data, and we're going to simply click on that import data to make sure the data import's working correctly. And it imported the data into Excel correctly, and so that's working well. So we're going to double click here to return to Plant Builder. And now we're on to the next task, which is to review the unit characteristics. So by double clicking that, I initiate a load profile and polynomial fit analysis. And this will do a few things. The first one of the things it does is perform a polynomial fit to the unit characteristics. And that's important because the polynomial fit is used to compute the optimized plant dispatch. And the other thing it does is it checks the data against the unit characteristics to ensure that the data extends far enough, that the unit characteristics cover the full extent of the power values that are used that the plant operates at. So after this analysis, we created 3 workbooks: the load profile polyfit, which has the plant and unit information and the polyfit unit characteristics, and also the head profiles for each unit. So let's look at this load profile polyfit to start with. So it shows the unit energy generation for each unit. It shows headwater and tailwater, and that's just to get a visual confirmation that the data is okay. It's one check of the data. And then in Unit 1, we can look at unit and power and head versus time. And one of the key calculations in this load profile polyfit workbook is the percent energy outside the unit characteristic limits. So this shows that 22.5% of the power of the energy that this unit generated was beyond the unit characteristics. So the unit, and the reason for this, we can look at this table over here, and it shows that there's two head values in this data set, 160 and 170. And over here, it shows the min and max power in the unit characteristics and the max power in the data. And it shows here that the max power in the data is 54.18, and the max power in the unit characteristics is 53 and 55.44. So this max power in the data has to be less than the adjacent values in the max power in the unit characteristics for it to include it in that data set. And because this is less than this, the unit characteristics at 160 feet of head do not extend far enough. So those would need to be extended by either by some form of extrapolation of the existing data, or a better method would be to see if there's more data that exists to actually make sure that those are right, or more test data exists. So that's a key output of this. I'm not going to fix that at this point. If I were actually creating a plant model, that's one of the things I would address right away, because it's necessary that the unit characteristics extend far enough to cover the full data range so that the following analyses are valid. So for Unit 2, these characteristics extend far enough because the percent energy outside the unit characteristics is 0. So these unit characteristics extend far enough for this data file. And then also there's head profiles for each unit. And so if we look at the head profiles, there were two heads that were analyzed, 160 feet and 170 feet. And this shows the polynomial curve fit. And a polynomial curve fit, which was a fifth order curve fit that we'd specified in the unit properties, fits the flow data nicely, which is what's fit, and then it also does it fits the efficiency data as well. So that's a reasonable fit, so we don't need to modify that. And then it also works well for 170 feet ahead. And there's more information here. It also shows the energy generation versus unit power. So it shows at what power levels most of the generation occurs. And then there's a time series plot of unit power in these workbooks. So by double clicking here, I return to Plant Builder, and it shows that that step was done correctly, and now we're on to compute plant efficiency curve. And as I returned, it unloaded those workbooks, so we don't clutter up Excel with too many workbooks, because it would slow it down and eventually stop it if we loaded up all the workbooks associated with these analyses. The next step is compute a plant efficiency curve, and this, I double click there, and what this will do is it does an optimized plant dispatch analysis, and there's 72 points here. It did that fairly quickly because this is fairly coarse, but ultimately we do it a bit finer if we were doing a demo here. And what this shows is the optimized plant efficiency plots workbook. So this shows for each head in the data that was specified, we had a 5-foot head interval specified in the data. At 160 feet, it shows the optimized plant efficiency curve, and it shows the optimized plant flow curve. And down below that, it shows the power values, shows the optimized unit power versus the plant power. So this is actually the combination of unit powers that produce the optimized plant efficiency curve. It shows that for each head that was analyzed. And then it also shows has unit data. So this is at the head level, and then it segments the data down into the unit level. So for Unit 1 and Unit 2, it shows more details. There's the data associated with the Unit 1 head 160, Unit 2 head 160. So it has quite a bit of information in this workbook. And one of the key items produced by this workbook is, if I go to the 2-unit plant, it's the optimized efficiency matrix. So this encodes the optimized plant dispatch in lookup tables. So in subsequent analyses, we don't have to use an optimization solver to come up with the optimized plant dispatch. And then there's also a scheduling efficiency matrix which covers the optimized scheduling for this plant. So I'm going to double click here to return, and once that's done, that finishes the solution. So the final solution, what we've done during the course of this analysis, if I open that directory, if I go demo back to here to this plant models, the 2-unit demo, notice that it's initially we started with this 2-unit plant workbook and the unit workbooks. Over the course of these analyses, we imported data, and that worked correctly. We created load profile polyfit, and so there's the load profile polyfit workbook and the head profiles. And we also have the optimized plant efficiency workbooks. And then the key items that have been added to the plant workbook include these polynomial fit unit characteristics, the optimized efficiency matrices, and the optimized scheduling, the optimized efficiency matrix, and the optimized scheduling matrix. So that's how one creates a workbook. You know, a new plant model with Plant Builder. If you want to get in touch with me, my email address is pjwolf@wolfwareltd.com. You can also go to the website DataWolff.com and get in touch with me through that website. Thanks for your attention.